Hey, this is Horner. We're going to look at the next thing, and this is an actual circuit. So this is question number 3. And for question number 3, we have a 10-volt battery, and that goes to 3 resistors, a 15 ohm resistor, a 10 ohm resistor, and a 6 ohm resistor. And remember, a resistor can be anything that resists electricity. So that could be anything as simple as a real resistor, or you could use a light bulb. A light bulb has a resistance. Your skin has a resistance. So when you put your hand on the Van de Graaff generator and then you reach out and touch somebody, there's a resistance across your skin. So lots of different things have resistance. So this doesn't have to be your typical resistor. We're going to use light bulbs. So we're going to talk about these as light bulbs instead. So let's go ahead and get started on this one. This one is in series, and because your resistors are in series, we need to figure out what that total resistance is. The sheet that's over on the right is called Voltage Loops by Kirchhoff, and Kirchhoff was a famous scientist that came up with some rules. And so he said that anytime you have electricity going through a circuit like this one, in a loop, all the electricity will add up to 0. So the potential difference here will equal the potential difference that is used up by all of the resistors. So let's go through and see kind of what that means. In order to start this, what we'll do, and I'm going to close this off, what we'll do is we're going to write on both the paper and on this Voltage Loops by Kirchhoff. To do that, the first thing we need to do is go ahead and write in what our resistors are here. Our resistors are a resistor number 15, our resistor number 10, and our resistor number 6. And we're going to write the resistances over here. So this is 15, this one is 10, and the last one is 6. The next thing we'll do is let's go ahead and write down the 10 volts. But we're going to subtract the battery potential difference. So we're going to say that this is negative 10. And we know that all of the total of the circuit, so the total of all these resistors, the voltage going through them, minus 10 should equal 0. And if that's true, then if this is negative 10, the total through the resistors should be positive 10. So far we've written down the resistances of the resistors. We know that the battery is 10, so we're going to subtract that off, and that means that the total here has to be 10 in order for us to get 0. Whenever we have resistors in series, we said earlier that we're going to add those. So this is going to be 31 ohms, because 15 plus 10 plus 6 should end up being 31. We now need to find out what is the current. So the current in this will be 10 divided by 31. So why is that 10 divided by 31? Well, remember Ohm's law says that current is equal to voltage divided by resistance. So this sheet and the setup that you have in the sheet helps you with that. We're going to take 10 divided by 31, and you end up with 0.322, and then I'm going to round the last number up to 6. Whenever you solve for the current, you want to make sure that you have 4 places past the decimal. That will ensure that all of the values that you get for the voltage over here will add up to something very, very close to 10. And I'll show you what I mean here. At the bottom of the columns, you'll see that it gives you some hints, tells you what to do. So in this one, it says this column will be the sum of the values, just add, so we did that. Here, this column will always have the same value for each bulb. So because the total is 0.3226, then each one of the bulbs will also have 0.3226 amps of current flowing through them. So this is 0.3226, and this one is 0.3226. Voltage, remember, is equal to current times resistance. And I have a current and I have a resistance for each one of these. So we're going to go through and do the math for this. So it's 0.3226, and we're going to multiply that times 15. You should end up with 4.839. we're going to multiply these two. We're going to end up with 3.226. And then finally, 0.3226 times 6 is equal to 1.935. So if I want to, I can get rid of this, and I can round this one up to 6. So let's go ahead and add the numbers up and see what we end up with. It's going to be close to 10. So we're going to take 4.839 plus 3.226 plus 1.936. And when I do that, I end up with 10.001. So that's very close to what we want. And that now is how we have found out what the current is in each one, and we know the voltage that goes through each of these resistors. So over on our sheet here, what we would like to do is we're going to write in what the voltage is for each one of these resistors. So for the 15 ohm resistor, we know that the voltage here, actually I'm going to get rid of that. Yes, I want to delete that comment. So what we'll do is we're going to put 4.839 volts, and we know that we get, as this goes through, we drop 4.839 volts through this resistor. Through the next resistor, we're going to drop, so we're going to say minus 3.226 volts, and then we're going to drop 6 volts through this resistor. And this is, we're going to drop not 6 volts, but we're going to drop 1.936 volts through this resistor. So as we go through, you'll see that we get closer and closer, and then finally we don't have any potential difference from here to here. And that is, that's basically how we can find out what the voltage drop is for each one of these resistors. We also know that the current through each one of the resistors is 0.3226. So we're not going to write that in. However, we do want to find out what is the power that each of the resistors has. So we can do this one of two ways. We can either use P is equal to IV, which is probably the easiest way to do it, or we can use the equation in series for power. So power in series, so I'm going to put a P here. So power in series is V squared over R. So I can either square my V and divide by R. I always think it's easier just to multiply the V times the I. So let's go ahead, let's multiply these and get our answer. So now we have our answers. We just took the voltage times the current for each one. We get 1.56 watts, 1.04 watts, and finally 0.63 watts. I can do one of two things to find the power. In fact, I'm going to do both because I want to double check my answers. And so what I'm going to do is put a line straight down there. I'm going to add these values together, and I'm also going to take my voltage and multiply it times my current. So if I multiply my voltage times my current, I get 3.23 watts. Over here, if I add these together, I'm going to take 1.56, add that to 1.04, and then finally add that to 0.63, and I get 3.23 right on the dot when I add them together. So because they're the same, I know that I have done this correctly. Now that I have the power, I can go back and put the power in for each one. And so the power for this one, for the 15 ohm, is 1.56 watts. So I'm going to put that in, 1.56 watts. For the 10 ohm is a 1.04 watts. And then finally for the 6 ohm is 0.63 watts. So that's the important part. If you remember in the lab that we did, the higher the power, the brighter the bulbs. So this one is has a brightness that is high. This one has the medium brightness. And then finally, this one has the lowest brightness. So if they ask you about the brightness, this is probably the best way to find it, is to go through and find out what the power is in each one. And once we know the power dissipated by each one of the resistors, we know which one is high, which one is medium brightness, and which one is a low brightness for a bulb. And that is the end of this video.